Hello, I'm Pavel and you follow the temDM channel that introduces you into the package for multivariate statistical analysis. Today we explore clustering the data. Let's open our familiar example of ILS spectrum image, and that time we would need MSA matrix, the full matrix, not compact one. Well, also we open the tool called clustering. Here we are. Let's design a cluster. First of all, we have to generate a scatter plot of two major components. Click plot XY, and very soon you get this scatter plot. Then we have to start a new cluster. Click new. You see some oval appears, and there are two lines. One is along the major axis of this oval. By dragging this line you can move your oval, and also if you drag only one end of this oval you can reorient it, or you can make it bigger like that. There is also a line along the minor axis, and by dragging it you can change the proportions of the oval. You probably notice that there is a binary image which shows you live the pixels currently included into your oval. That gives you a good idea about the connection between the energy space and the real space. Now suppose that we would like to cluster the only one variation trend in our scatter plot, the trend which is at the right side of our scatter plot. So let's place accurately our oval at that variation trend, something like that. Design carefully the position and proportions of our oval. Yeah, maybe like that. And then click store. So you see that all these points on the oval now turn to be red. That means they are included in cluster number 1. We can close right now the scatter plot. We don't need it anymore, and everything is stored inside the matrix. We can check that. Just click plot XY again, and soon you get the scatter plot where part of points are red. It means they are included in the cluster number 1. Close it again. Also we can anytime visualize the special distribution of cluster number 1. Now let's open our familiar tool Proceed PCA, and you will see that the whole PCA procedure can be run not with the whole set of data, but only within one selected cluster. Let's extract PCA components by clicking PCA, and now you see the difference. The system recognizes that there are clusters in our MSA matrix. So it asks you what you are going to do to treat cluster 0. Cluster 0 means no clustering, or to proceed with some selected cluster. That's what we are going to do. We input cluster number 1 and press OK. Well, now cluster 1 is prepared. And then component 1 and 2 are extracted within cluster 1. It should be finished soon. Well, here we have 2 loadings. Let's inspect them. Loading of the first component. Interesting is now this loadings is quite logical. It's different from what we had when treated unclustered data. That's because we selected only one trend of variation inside our data cube, and now this variation can be readily picked, and it is actually quite logic. If we inspect the second components, we see that that is just noise, and I can assure you that the components with higher index are noise as well. Well, close these loadings. Now we have also scatter plot. It's quite different from what we saw in unclustered treatment, because now we concentrate on one trend only. Let's close it. It's all stored in the matrix, and script plot we don't need at all. Now let's run reconstruction. Reconstruct, and you have a warning: data are clustered, use clusters. Yes, we will use clusters. We have the list of choice. Right now it's only one cluster, and we choose to reconstruct with only one component, and click this, the second one. Well, reconstruction proceeds. It's all within cluster 1. Actually, what does it mean? It means that the whole pixels not included in cluster 1 will be just ignored, and in the final data cube it would be 0 there. Well, we approach the final step of reconstruction, converting to cube. It takes time. Now we have the reconstructed data cube. Let's compare that with the original data cube. Open else cube. Here we have it. Then click at the reconstructed data cube and run twin view spectrum. Just place this spectrum conveniently. Change the scale, the contrast of display. And you see blue noisy original spectrum and red reconstructed spectrum, which is much nicer. We can travel along our data cubes and see improvement everywhere, but when we go outside our cluster 1, red curve suddenly disappears. It's just 0. That's because we didn't make reconstruction outside our cluster 1. Good. So let's stop this twin viewing just by closing the display without saving. Now I would suggest to save all changes in our MSA matrix, because we did a lot of job with clustering, and all the steps are currently inside this matrix, but it's still not saved. So let's save it and update the file. Well, the reconstructed data cube, I will close it without saving. It's not a big deal to restore, and also we don't need the original data cube. Now let's practice in designing many clusters. I will open another example. That would be example from real life, not simulated one. And probably we don't need the simulated else anymore. We close it, and the Proceed PCA tool we close as well. In this object I have already extracted something like 10 or 15 principal components, and let's have a look at scatter plot. So you see quite complicated topology of the object. We start clustering, and first of all let's account for the most pronounced data variation. New cluster. We cover first this variation branch. Good. Let's click Store, and we have the first red cluster. Well, the second pronounced variation branch is this one. Let's cover it with a new cluster. Yeah, something like that. Good. And store it. We have two clusters, red and green. Now we can try to attend this region, but there is something suspicious. To me it looks like there are two variation branches heavily overlapped, and probably we look at them from projection which is not optimal to understand what's going on. So let's try to look from another projection. For instance, let's generate scatter plot of third and second component. Oh, we must have the matrix in front. Yeah, now it must work. Good, we have another projection, and there you can find our old red and green clusters. But the interest for us is this unclustered black points. Well, looking at that projection, I would say that there are even 3 different variation trends, and we will start to isolate this one, which looks a little bit apart from the other. We will design cluster in a new scatter plot, new cluster, and cover this left variation trend. Something like that. Store. We have new blue cluster. Now let's treat this small branch, new cluster. We have to cover this accurately, no overlap with neighboring variation trenches. Store. Okay, we have a pink cluster. Maybe you notice that although we designed a cluster in one particular scatter plot, the points are automatically repainted in all available scatter plots. This way you can simultaneously keep a look at all projections and understand better what's going on. Yeah, in particular, maybe you notice that when we created the pink cluster, we accidentally catched the part which apparently belonged to the green cluster. Just keep that in mind. We will correct that at the... Well, now that's time to attend the last visible segregation. I mean this one. click New, and we have our ellipse. Place it carefully at the place of interest. Maybe something like that. And click Store. So we have a yellow cluster. Now we have to fix the problem. Remember, we always contaminated the green cluster, first with pink points and then with yellow points. Now we have to restore the original green cluster. Let's click Correct. And we manually type we want to correct green cluster. We have a new ellipse and we place it such a way that we cover all green cluster how we use that, and click Store. So the green cluster is restored. Well, I think it was an adventure. We explored the structure of our data in some three-dimensional energy space. You can try even more dimensionality, but I think it would be a challenge. I have to mention that all these clusters can be treated by PCA as a package if you press PCA here. And you also can extract the average spectrum for each cluster. So today we explored the clustering tool. We already covered the most of functionality of the temDM MSA package. Most but not all. Please continue to follow temDM channel.